This movie is for Learning Target 8, Evaluating and Graphing Exponential Functions. Your soccer team wants to practice for a drill a certain amount of time each day. Plan 1 has you practicing 5 minutes today, then 1 minute more each day than the previous day. Plan 2 has 1 minute today and then twice as much as each previous day. These plans are different in that in Plan 1 I'm adding a certain amount, and in Plan 2 I'm multiplying by a certain amount. These two plans are different in that Plan 1 is arithmetic and Plan 2 is a geometric sequence. That's what we're going to be learning about today, is geometric sequence. Plan 1 is linear. And we're going to learn about exponential. Key concept, exponential function, is in the form y equals a times b to the x, where a is not 0, b is greater than 0, and b is not equal to 1. Looking at these two equations, I've got y equals 2 to the x. This graph is growing exponentially. This graph is decreasing exponentially, y equals negative 2 to the x. Notice x is to a power. That is true of all exponential functions. Over here we see that this guy is decreasing because my growth rate is 1/2, less than 1. This guy is increasing closer to 0, closer to that axis, because my growth rate is less than 1. And that's what we're going to be looking at. Exponential function, here's our general function rule. Just like linear had y equals mx plus b, exponential function has y equals a times b to the x. We're going to evaluate t of n equals 4 times 3 to the n, where our domain is negative 3 and 6, so we'll plug in negative 3 for x, and we'll plug in 6 for y. So plugging in negative 3 for x, I get 4 over 27. Plugging in 6 for y, I get 2,916. We can see that by just adding numbers on this side, I have to multiply by a number on this side because it's growing exponentially. Let's take this equation and find for a domain of negative 2, 0, and 3 what the y values will be. So what I do is I take y equals negative 2 times 3 to the, now I'm plugging in negative 2. I plug that in, or use my properties. So it's negative 2 over 9, which is negative 2/9. Then I'm going to plug in 0. 3 of the 0 is 1, so that's negative 2. Then I'm going to plug in 3. So negative 2 times 3 to the third. So I'm going to get negative 54. So you can evaluate exponential functions by plugging in certain domain values. Suppose all the x values in a table have a common difference. If all the y values also have a common difference, then we say that it's a linear function. We say that we have a constant increase or a constant decrease. That's linear growth. If all the y values have a common ratio, meaning we're multiplying by a number, then we say that we have an exponential function because we're going to be multiplying by something, not adding. Let's look at each of these and determine if we have linear or exponential. So in this top one, I'm adding 1 each time. And here, I can see that I'm multiplying by 3. Because I'm multiplying by 3, we say that this is a common ratio. So this is a geometric sequence, it's exponential. Let's look at this equation. Because this equation is like the form y equals mx plus b, where my slope is 3, this is linear. If it were exponential, I would have an exponent up here. And we do not have that. We do not have an exponential function. Let's look at these guys. Here I am increasing by 1, and down here I'm adding 2, add 2, add 2. This must represent linear. If you look here, notice where x is. X is the exponent. So this is an exponential function, since x is the power. It's exponential. Let's look at a word problem. Biology. Suppose 20 rabbits are taken to an island. The rabbit population triples every half year. The function f of x equals 20 times 3 to the x, where x is the number of half-year periods, models the situation. How many will there be after 2 years? 2 years is how many half-year periods? 2 years is obviously 4 half-year periods. So what I'm going to do is let x be 4. So I'm plugging in 4. I get 20 times 3 to the 4th. (1,620 rabbits. So we can see that the rabbit population is growing exponentially. 30 flower beetles undisturbed with this function. It's doubling each week. I can see that my growth factor of 2. How many will there be after 56 days? Is how many weeks? So to get how many weeks, we would do 56 divided by 8, which is, we get 8 weeks. So I get 30 times 2 to the 8th, which gives me 7,680. 7,680 beetles after 56 days. We could say that that beetle population is definitely growing exponentially. Just a reminder of our exponential growth functions and what they look like. Let's look at photocopying. How many photocopiers allow you to choose how large you want an image to be? Many of them do. Here's your function. Models the new size of an image being copied over and over in 150%, where x is the number of enlargements. Let's have this column be f of x. So if I have a domain of 1, I'm plugging 1 in for that function. So I'm doing 1.5 to the first power, and I get 1.5. You could plug this guy into your y equals on your graphing calculator, and then go to your table of values to get this, because then if you scroll, you would get 2 is 2.3, 3 is 3.4, 4 is 5.1, and 4 is 5.1, 5 is 7.6. Next, what we're going to do is graph those. And I'm going to set a scale. I know it's in the first quadrant. Of every other one is 1. So my scale is 0.5. And I'm going to plot these. 1, 1.5. 2, 2.3. 3, 3.4. So far it looks kind of linear. 4, 5.1. 5, 7.6. You can see it starts to grow exponentially. So this is an exponential growth. You could practice with these. You could practice with your graphing calculator on these problems. I'm going to move down here. There's another word problem you could use for retake contract work. I want to show you this problem. What is the solution to this guy? So what we see here with 2 to the x equal to 0.5x plus 2 is I see two equations. I see the left side and the right side. And to solve this, we're going to use the graphing calculators, and we're going to take what's on the left side and set it equal to y, or y1 is equal to 2 to the x. Then we're going to take what's on the right side and set that equal to y2 is 0.5x plus 2. Now the meaning to this is I'm seeing where these two equations intersect, where they are equal to each other. So I'm finding their intersection point. So that's the first step, is to write our two equations, and that's what we have. The second step is to graph them on a graphing calculator, and this is what you'll get, these two graphs. The third step is to go to the calculator feature, calculate intersection to find where the points intersect here and here. When you go to intersect, it will say left bound, in which case you want to go to the left point of the intersection, press enter, and then go to the right bound, and go to the right side of it, press enter, and it will calculate the intersection of the two lines in between those two bounds. So it'll give you the two solutions, the first one and the second one. And that's a quick way to solve what we have essentially is a system of equations, is to graph both on the graphing calculator and see where they intersect. We will do more practice with this in class, so that is the end of the movie. Thank you for watching.